Welcome back everyone to another video, and we're back with the ShibaSoku. This is the final video in the series for this thing because I need to move on. I've had enough of this unit and we need to get back to some main projects, not these side quests that I didn't really want to take on. Excuse my voice if I'm a bit out of it, a bit sick. I've got a cold or something and I'm just trying to get through some videos at the moment. It's a bit of a struggle. But anyway, one of my favorite quotes is that you didn't make a mistake if you learnt from the experience. And I thought this thing was a big mistake when I bought it. I thought I was in way over my head, but I got to learn a lot along the way. And we have something at the end of this where I feel like I've learnt a lot and we have a useful tool for doing future projects. Now, in this video, we're going to do some just go over the calibration for the unit, or the best I could do with it, and we're going to test it with an amplifier. So let's get started. Now, I thought I would just start off showing you the unit as is, as I've calibrated it, with all the covers on, with the load bank sitting on top of it. I calibrated everything as it will normally sit because this thing is quite thermally sensitive, so we do have to be careful with it. I want to open the cover and show you a few things, but we'll do that afterwards because as soon as I open the cover, it's going to start drifting all over the place. Now, to do the calibration on this, I started with the output oscillator section because we needed to use the oscillator as a reference for calibrating the input side. The issue was, like, what am I seeing here is the voltage and the frequency. We don't know if the oscillator was right, or the voltage, or if what it was reading was right. We could have been compensating one for the other, vice versa. So we needed a known, well, better reference than the unit itself. So I ended up using my multimeter, which does have frequency and voltage measurements, and there are trim pots in the oscillator section that we can tweak. There's a trim pot for oscillator level, which allows us to adjust the amplitude, which is currently 7.75 volts, and we are reading 7.75 volts. This is not what it was reading originally. It was quite out of whack. But I used my multimeter to set the voltage for the oscillator, and then I knew that even though this was wrong, the voltage that this was putting out, like what it was supposed to be putting out, this isn't based on any measurement inside the unit. This is just what's being commanded from the unit, matches what is actually coming out of the unit. So we had 7.75 volts, 7.75 volts. So that was all good once we did a little bit of tweaking. And then we started having a look at the oscillator, which was a little bit out. Nothing was crazy out of spec, just a few little tweaks here and there. We have 1 kilohertz coming out of the oscillator, and we are reading 1 kilohertz on the multimeter also. Bit of a jump cut here. I forgot to show you that, yes, the other frequencies are also perfect. Well, not perfect, but as good as it can get for an old girl like this. 50 kilohertz, go all the way up to 100 kilohertz, and a little bit out there, not too much. And 109 kilohertz is the max range, and very close, as close as you're going to get. So I got the frequency and the voltage output as good as I could get it on the output side of this, and then we can use that for the input side for doing some tweaks and adjustments. Now, moving on to the input side measurements, like I said, I've already done all the voltage adjustments, keeping in mind the voltage is sort of like a single adjustment. There's no real offsets or ranges or anything. It's the best of all worlds. You basically can just run through some different ranges and hope that it's within the ballpark of what you're looking at. And as good as I can get it, it is basically bang on and good enough for what we need. Now, all the functions in this unit are on separate cards with separate adjustments. So the dB level, gain, whatever you want to call it. It does have a separate set of adjustments. So on the dB side of things, we have a 0 dB adjustment and a minus 80 dB adjustment. So if I have it on 0 dB, which happens to be 1 volt, and then I switch to dB reading, we can see we're pretty much bang on there. The other adjustment is minus 80 dB, which I have done also, is, there you go, bang on. And considering we are talking about 100 millivolts for this one, I'm quite surprised that this is within range. But that you also do have to have this loaded. If you turn this off, then we do end up with some residual voltage and whatnot. So you do have to have the input impedance set correctly to get an accurate reading. So the phase is probably one of the last things I wanted to check on this unit to ensure it was working and that I can use it in the future, because we're going to be doing some audio transformers and other things in the future, just to make sure it was working. Now, I thought I was screwed here because there are no phase adjustments on the output side of this. I didn't really have anything else on hand, but lo and behold, my audio generator on my computer with my DAC, which is very clean, does have phase shift options available, so I decided to use that as my reference to test this thing. I did have to zero it out because this was floating around a little bit, but that's perfect now after a bit of a tweak. So if we go to, say, 45 degrees phase, looking good. Go up to 90. Pretty much bang on also. Go to 120. 20 is good, and we'll take it right up to the edge of the range, so 179, and we're basically bang on. So we can go to, say, minus 90, and we are basically perfect. Minus 150. There you go. So I am very happy with this part of the analyzer. It didn't take much to adjust, but we know it is working correctly. So all that leaves is the rabbit hole of distortion measurement. So the distortion measurements on this thing have driven me to the edge of insanity, almost trying to wrap my head around what I'm trying to achieve, what is a reference in regards to this thing and what it should be measuring. I've decided to get the noise floor as low as possible to null out as much as I can and to just leave it there for the time being. So this is the residual distortion with a 1 kilohertz sine wave out of my DAC. That is all good. Now, this is where things get interesting. I have some reference files here that are supposed to simulate total harmonic distortion. Now, what is this trying to measure exactly when it says distortion? I don't know. It has all the filters available, so I'm assuming it is distortion plus noise. But it is not clear in any of the documentation about exactly what it is doing. These files I've given to other people who have tested on their equipment, and they've had different readings. Everyone is sort of a bit all over the place, and it seems to me that measuring distortion is a lot of the times a bit of bullshit, and depending on the realm you operate in, what you're using as a scheme for filtering and your measurement equipment and your sources and whatever, you're going to get completely different results from environment to environment. So I don't know what I'm chasing with this unit or if the values it's producing are accurate or inaccurate. In saying all that, let me show you what a 1% total harmonic distortion is supposed to show on this unit with this test file. And this is the reading I get. As you can see, we are reading, yes, 1%-ish. That is 1.09, almost 1.1. And if it trips over to 1.1, we've got a 10% variance. Is that variance because this is wrong? or because the file isn't correct, I don't know. If I turn on the A weighting, I can cut that in half. So I don't know what I am chasing in regards to this. I will show you some other frequencies, distortions. So here's a 5% total harmonic distortion figure. And we can see that it is, yes, 5%, 5.3%, and which is fair enough. And then I turn on the A weighting, and now it goes up. I don't know what the hell is going on. If I go to 0.1%, we are looking at today, standing on 1 foot, 1.06, 1.07, 1.06. That's pretty good, I think. Turn on A weighting, and we're under now. So take your pick. Let's go to 0.01%. So yeah, that's a ways out, I would say. A weighting again. Basically bang on, almost. Fascinating. I am not an audio engineer. I do not know this stuff inside out. I do not pretend to. I am just screwing around, restoring amplifiers, trying to add tools that I can learn from and that give me more information about the things that I am doing when I restore amplifiers and whatnot. So in regards to distortion, I am leaving it as is for now. The only thing I will say that I can adjust some of the things on the distortion measurement board, and I can get this to basically bottom out at 1% distortion. I can get 0.5% to be basically bang on. I can get a lot of the ranges to be almost bang on. But if I do that, it throws out the nulling and the noise floor for this unit overall when it has a clean signal. And because I don't know this is gospel or a valid reference, I can't chase it as my benchmark. So that is where I'm leaving distortion for the time being. Right, so just before we get to the amplifier testing, I'll just take you through the adjustments one more time. I've learned a lot about what most of them do, well, my understanding of them anyway. In case anyone happens to inherit one of these things and they don't want to spend a freaking eternity trying to understand what everything does. So the front two boards are related to the oscillator section. The amplitude or voltage gain adjustment for the oscillator is buried down here. So that can tweak the voltage output of the oscillator to match whatever is on the screen. I haven't messed with the AGC bell or any of the other pots except for these ones here. So these 4 pots here are related to the frequency. Took me a little while, but they're actually split up into ranges. So A, B, C, D. A is 0 to 99 Hertz. B is 100 to 999 Hertz. C is 1 kilohertz to 9 kilohertz. And D is 10 kilohertz to maximum 109 kilohertz, I'm assuming. So you can tweak those if you need to make sure the oscillator is running in tune with what it is displaying on the screen again. The board behind that is related to phase. I've only really messed with phase 0, so that's zeroing out the meter. Plus 90 degrees, I basically set 90 on my computer and then dialed that in, and then minus 90, same deal. Didn't mess with ratio, didn't mess with phase range, haven't touched anything else. There is an LED here also that lights up. I don't know what that does exactly, but anyway. Next board is all for distortion measurement. There's 4 pots on the left here. Basically, I tweaked all those a little bit for the lowest noise floor. If anyone has questions about that, send me a message because it's too sort of in-depth and finicky to go into here. Over here we have nulling, so basically these were set for the lowest residual distortion, and there's a couple of trimmer capacitors for high frequency tweaks. Those 2 little green things there that you can adjust also. If you mess with this, make sure you measure all the values before you go screwing around so you can go back to where you started if you need to. Behind that, voltage measurement and dB measurement. So volt gain will adjust the display. So make sure you can tweak that a little bit to get that right on the money. The 0 dB adjustment is basically for adjusting the display. Minus 80 dB, same deal. Didn't really touch meter zeroing or the CCIR offset either. Okay. Board behind that is for filtering. I finally figured out, and the only things I did play with a little bit was the CCIR gain and the A gain. So basically when those filters are engaged, the voltage can drift on the display. So I did have to tweak these a tiny bit to make sure the voltage was basically on the money with filters enabled. Finally, the last 2 boards, or the first 2 boards, I mean, they are boards A1, A2. These are the actual input boards where all the relay switching and everything is happening. I did not touch anything on these boards, but there are some adjustments here that I have no idea exactly what they do, and I would not mess with them if everything else is fine. Hope that helps someone, maybe, or if anyone who's interested in it. Alrighty, so we're all set up, ready to go. I have chosen 2 little test subjects here. We have a low-powered capacitor-coupled amplifier, Harman Kardon 330B, and a special guest that you will see at some point in the future, an NEC-A10X, straight from Japan. A very special and unique amplifier. Just thought I'd show you the setup quickly just to give you an idea of what's going on. The oscilloscope is connected directly to the monitor output on the analyzer. We'll talk about that more shortly. I have my multimeter hooked up to the load bank as a separate set of eyes just to keep an eye on things. And the load bank, these are 300 watt power resistors plus a massive heatsink. They can take a lot of current, so there's nothing to worry about there. The output cables from the oscillator are Mogami shielded cable going straight into the amplifiers, and I even went to the extent of using Mogami shielded speaker cable coming to the load bank and from the load bank back to the input of the analyzer. I did a lot of testing with different cables, and my best results were to shield everything other than the load resistors, of course, because we can't really do anything with those. There was a significant difference running unshielded speaker cable. I'm not saying you should do that for your speakers. This is just for analysis and because we're chasing into some very, very minute measurements. And you're going to see that when we get to the NEC amplifier. So let me put the camera down and let's get started. So let's get started with the amplifiers. We're going to start with the Harman Kardon 330B. Just to give you a bit of background quickly, the monitor output will show whatever mode it is running in. So at the moment we're on distortion, so this is only showing distortion. If we're on level, then we actually see the sine wave and any clipping or anything like that. So unfortunately we cannot see clipping while we're in distortion mode. Bit of a downside, I do prefer to see clipping directly, but we will see it in the distortion measurements anyway. And this oscilloscope is going to auto scale because the monitor output will auto scale as the analyzer changes ranges. So you will see big waveforms, little waveforms that's going to keep moving around. The rating for this Harman Kardon is 0.5% THD. That is its official spec. So we're going to go to 1 watt, 10 watts, and then maximum power, which is around 22 watts per channel. So we're in distortion, so let's start bringing it up. And 2.8 volts is about 1 watt. So there we go. We're seeing just residual noise at the moment. If we go to level, there's the sine wave. So we'll go back to distortion. Holding there nicely, we're looking at about 0.7 and 0.8. So yeah, we're not too far off. I'm going to go around this side. We can try out the weighting noise filters. So we'll go to A weighting. Does bring it down a little bit. We could try a 400 Hertz high pass filter if we want to see if there's any power supply noise. And yeah, so that's 1 watt per channel. So let's take it up to 10 watts, which is 8.9 volts and 0.05%. And between the channels, 0.06. So it's a little off between the channels, not too bad. Have a look at the A weighting now. And you can see the difference on the scope also, how it's being averaged out. Barely any difference at 50% power. And check the sine wave again. Still looking good. All right, so we'll go up to max power. So what we can do is go to this setting. We'll bring the sine wave up. Find that clipping point. There it is there. So that's about max power. And at distortion, we are looking at still about the same. 0.05. If I bring it down a little bit more. Yeah, it's still about the same. 0.06. And if you push it into distortion, you'll see the value just suddenly go through the roof. Yeah, so I'll give this one a break. This one can't handle a lot of power. It's only a tiny little amplifier. And that is well beyond its specification. Is it accurate or not? I don't know, but I guess we're more looking for consistency and anything abnormal between the channels. But let's switch to the NEC, because this is basically a power amplifier, not a receiver, and this thing is going to be a hell of a lot cleaner, I think. Okay, final setup, NEC-A10X. This is basically a solid power amp. It's going to put down some impressive numbers, I think. So I just want to show you some interesting things that we're starting to get into the world of as we get into these very low numbers. So if I take this up to 2.8 volts, which is about 1 watt, you can see we're already down to 0.02%. But you want to know what's interesting? Look what happens when I turn the lights off. Watch that distortion figure. So even the lights are affecting the value. I'll put it on channel A. Yeah, so this is the sort of stuff that we're starting to screw with now, and that should give you an idea of the craziness of what we're going to. So I'm going to leave the lights off just for this part of it. And just so you know, the Harman Kardon, it didn't matter because its distortion was above this sort of threshold of noise, so it didn't really matter. But anyway, so that is at 1 watt. We are already putting down very good numbers. So we will go up to 30 watts, which is 15.5 volts. This is half power. 0.005%. Very, very impressive. If I turn on A weighting, 0.003. So very good. Very, very, very good. So this is 50% power. I'll take it up to its rated power, which is 21.9 volts or 60 watts. Still hanging in there, basically the same value. Just well, remember, check between the channels, see if there's much variance. Basically no difference. That proves that the amp is happy and the analyzer is happy. It's quite well balanced. I trust this more than the Harman Kardon, which is going to float around a bit. So let's take this amp up to its clipping point. It hasn't clipped yet. Whoop, there it goes. So you can see that distortion. So I would say probably about there is the limit. That's when the distortion's starting to creep up, which is 27 volts, which is 90 watts per channel. So that's a pretty lazy 50% on top of its rating. Very, very impressive. I can't wait to do some work on this thing. All right, so that is it. That is the end of the ShibaSoku video series. It works. It gives us numbers. We can use it to evaluate some things. If these numbers are meaningful to you, I don't know. But it's another tool that we have in the arsenal of restoring amplifiers and seeing if they're balanced or if there's anything unusual that we can't hear. And I hope you enjoyed this series. Like I said, I'm over it. I didn't want to do any of this, but the opportunity was here to document rebuilding this thing. Maybe it'll help someone in the future if they come across one. And I'm going to figure out where all this is going to go and how I'm going to use it in my future setups. It's going to have to join my collection of test equipment somehow in some sort of a rack, but that's a story for another day. Hope you enjoyed this video series, and I will see you in the next video.